Okay, Professor Will, I know you are there.
Yes, I'm here.
So, yes,
Yes.
and I know with you, we have to start exactly at 10.
Yeah.
Let me just give again 2 minutes to see because I can see people are joining. Then I will start to open the ceremony. I hope the people that will, our moderator are already there. Moderator, can you put your hand up? Dr. Awodo, are you there?
Yes, Prof, I'm here.
Okay. Okay, very good. So let us give 2 minutes again, then we start. Is Dr. Hans there? Okay, Dr. Annie Adina, you are there?
Yes, good morning.
Okay, okay, morning. So the three moderators are ready. Let us wait again another 1 minute because we said 2, then we start. Okay, let us start. Distinguished guests, esteemed colleague, and passionate lover of mathematics, it is my distinct honor to welcome you on this International Mathematics Day. Today we celebrate not only the abstract elegance of numbers and equations, but also the transformative power of applied and industrial mathematics, a discipline that has shaped our world from its very inception. As we reflect on the genesis of our universe, we are reminded of a profound message from our sacred text. In the book of Genesis, God bestowed upon humankind the divine mandate: be fruitful, multiply, replenish the earth, and subdue it, and have dominion over the fish of the sea, over the bird of the air, over every living things that move upon the earth. This verse speaks to our enduring responsibility to harness our intellectual gift, to understand, model, ultimately understand the natural world. Mathematics in its pure and applied form is one of the gifts. It is the language with which we articulate the law of nature, laying down framework that allow us to command, shape our environment. Mathematics, especially applied and mathematics, have a specific role, a very important role. It is the bridge between abstract theory and a real-world problem. It provides us with the tool to model complex systems, from predicting weather pattern, optimizing supply chain, to designing advanced medical imaging techniques that save lives. Industrial mathematics, on the other hand, is the engine that drives innovation in industry. It fuels the design of algorithms that power our digital age, optimize the process that keep economy driving continually, pushing the boundary of what is possible. Let us consider many facets of this discipline. We start with innovation in technology. Every technological marvel we enjoy today, smartphones, satellite, renewable energy system, all it experience mathematical model that guide the development. Applied mathematics gives structure to our creativity, transforming one idea to tangible, efficient solution. Let us speak about economy and industrial progress. In the competition area of the globe, industrial mathematics enable us to optimize production, minimize waste, and maximize efficiency. Industrial mathematics has become indispensable in managing the complex logic of modern commerce, ensuring that industry remain agile, responsive to ever-changing market dynamic. Let us speak about healthcare and life science. From the modeling of disease spread to the design of precise diagnostic tool, mathematics has revolutionized medicine. In applied research, mathematical modeling is the stone corner of predictive analytics that inform public health policy and save countless lives. Let us speak about our environment. As we face the challenge of climate change and economical degradation, mathematical models are our guides. They help predict environment change, optimize the use of natural resources, design sustainability practice, and that honor our role towards the earth. Of course, as African, because today is a mathematical day, but it is ASIAM that decide to gather people. We thank Professor Will, the president of ACAM, to be. I would like also to state that mathematics and its heritage in Africa. Our journey today is not only global, but also deep root in the rich and diverse heritage of Africa. African civilization have long contributed to collective knowledge of humanity. Mathematics is no exception. From the majestic pyramids of ancient Egypt, built with precise geometrical planning and intuitive understanding of mathematics, to the encrypted astronomical chart of the Mali Empire, Africa's historical contribution have been both profound and pioneering. Consider the great mathematician, scholar who work tangentially border. We are speaking here about the wisdom preserved in the ancient monastery of Timbuktu, stand as a testament to a tradition of regular inquiry and scientific advancement. The text, often written in Arabic, local dialect, reveal a sophisticated grasp of algebra, geometry, astronomy that guide navigator, architect, and engineer. In more recent time, African mathematicians have emerged as leaders in applied research in industry innovation. Their conclusion in the field range from cryptography to data science have been pivotal in addressing challenges unique to our continent and beyond. Their work continues to inspire a new generation of scholars eager to build on a legal wide brazen neutral in science and technology. This lineage reminds us that mathematics is a universal language, one that transcends culture, geography, and time. It is a field where contribution of our African brother, sister stand shoulder to shoulder with those from every corner of the globe. Now, the transformative impact of applied and industrial mathematics for the young people that are listening to us. Let us now delve deeper into how applied mathematics have changed our world, both in theory and practice. revolutionizing communication and information. The digital revolution rests on the backbone of mathematical algorithm. In coding theory, cryptography, network optimization, mathematics ensure that our communication are secure, reliable, and efficient. Every email sent, every video stream, every piece of data transfer across the globe is acceleration of applied mathematics at work. Driving sustainability development. As we confront the imperative of sustainable development, mathematical model provide clarity amid complexity. Whether it is predicting energy demand, modeling urban growth, or optimizing renewable energy grid, applied mathematics help us forge path towards sustainable future. Industrial mathematics too, of course, is crucial in developing technology that reduce waste, improve resonance allocation, enhance overall industry efficiency. Let us speak about the enhancement of industry process. In the heart of industry, mathematics is the silent architect. It allows engineers to design systems that reduce costs, increase safety, elevate productivity. From the oil rig in the deep sea to the manufacture hub in our city, mathematical model ensure that operation run smoothly and efficiently. Turning challenge into opportunity for innovation. Let us speak about advancing science research across vast landscape of scientific research. From physics to biology, mathematics serve as both a tool and a language. It provides the structure for developing theory that explain natural phenomena. For simulating experiment in virtual environment, for analyzing vast data set that would otherwise be ununderstandable or incomprehensible. Applied mathematics transform raw data into meaningful insight, fostering discovery that propel humanity forward. Inspiration from divine mandate and human ingenuity. Let us circulate back to the ancient mandate inscribed in our sacred text. A call for humankind to exercise dominion over creation through understanding and wisdom. Mathematics is the very embodiment of that divine command. It is through mathematics that we learn to understand the underlying order of cosmos, to harness the force of nature to elevate the human condition. Every equation solved, every model refined, every algorithm optimized is an act of creative rebellion against the chaos of the unknown. In applied and industrial mathematics, we find a blend of art and science, a discipline where abstract beauty meets practice necessary. Here, we see not only the spark of human genius, but also the guide hand of a creator who imbue us with the capacity to shape our world. Now, a call to passion and commitment. Today, I invite all of you to fall in love with mathematics. What I'm trying to say is that if mathematics was a religion, I am Professor Atangana, the prophet of mathematics, asking you not as a mere academic subject, but as a living, breathing force that empower our daily life. Let us cherish its elegance, celebrate its power, harness its potential to drive progress and prosperity. And to our youth, because we realize that in our continent, our youth are not interested to do mathematics. But today, let me tell you something. embracing the challenge and mystery of applied mathematics. Let your curiosity be your guide, your passion, the engine that propels you towards discovery. In every problem you solve, see a glimpse of infinite possibility that lie ahead. Your work in industrial mathematics is the stone corner of progress. Continue to push the boundary of what is possible. Let every breakthrough remind us that mathematics is not just a tool, but a force for positive change in our world. Recognize that mathematics unite all of us. That's why today we can sit here, we see people from all over the world, Professor Will from Europe, people from India. It is because of mathematics. It bridges culture, transcend languages. That's why I'm speaking with broken English, because the language I learned was French, but with mathematics, we have to make sure that we are together and create a sharing understanding of universe we inhabit. Whether you come from Africa, Europe, Asia, or any corner of the globe, you are part of the grand tape stream of knowledge and innovation. In conclusion, as we stand as a Congress of History and Innovation, let us remember that applied mathematics, applied and industrial mathematics are not a relic of the bygone area, but living discipline that continue to shape our future. From the divine mandate that call upon humanity to be steward of the earth, to the modern innovation that sustain our industry, enrich our life, mathematics remain at the heart of human progress. Today, as we celebrate International Mathematics Day, let us pledge to continue this journey of discovery with unwavering commitment. Let our mind be as boundless as the problem we tackle, and our heart as a steadfast of the solution we create. In every formula, every model, every breakthrough, we honor the legacy of our forebear and kindly the spark of the future genuine. May you live here inspired, not by the beauty and the power of applied mathematics, but also by the knowledge that through mathematics, we hold the key to unlocking the mystery of the universe. And in doing so, we fulfill the sacred call to shape and steward the world. Thank you, and the spirit of discovery guide all of us.
Thank you very much, Dangana. I hope I am audible.
Yes, you are audible. We can hear you.
Thank you very much. Greetings, everyone from all over the world. I am Awodwa Magingi. I will be the session facilitator, and my co-facilitators, Dr. Ini, as well as Dr. Ans. Prof. Atangana has already welcomed us, and I think one thing that I've picked from what he said is that mathematics is the law in which we articulate our nature. Mathematics is the key in understanding the universe. And I think that's very powerful, because whatever we do, I believe that it revolves around mathematics. And our theme for this event, it is equations of empowerment, which is really attributing to charting Africa's industry, and as well as, technology, which is rooted really around mathematics. And without wasting any time, I would like to call upon our podium, our virtual podium, Professor Makinde, who will be highlighting the objectives of ASIAM. Over to you, Prof. Thank you.
Okay, thank you very much. Yes, I will just share this. Can you see the share screen?
Yes, we can, Prof.
Okay,
Yes,
now
Prof.
let me start by, we thank God for giving us this opportunity to participate in this inaugural event as ASIAM in celebrating the International Day of Mathematics. We know globally the world is celebrating the International Day of Mathematics, and in fact, the UNESCO and all other organizations, they are also in it. So we take this opportunity also to share the objective of ASIAM as part of the international organization based in Africa, whose objective is also in propagating the impact of mathematics, especially the applied mathematics in industry, in revolutionizing the technology within and outside African continent. Now, I would also like to say a word of appreciation to all those who are participating in this event with us. We really appreciate your participation. Now, come back to ASIAM. As you know, ASIAM is just a short form or acronym for Africa Society for Industrial and Applied Mathematics. And this initiative started last year officially, and we thank Professor Wills for his support as the president of International Society, the organization, ICIAM, International Congress of Industrial and Applied Mathematics. We thank Professor Will and all other people who come to make sure that this society come to fruitfulness. And you can see most of the things I'm talking about right now. You can check our website, asiam.africa, and you will see most of it. In fact, to cut the long story short, the ASIAM is a transformative initiative that drives research, education, industry, and policy progress. It provides a platform for African applied mathematicians, scientists, and engineers to interact and address local challenges, foster innovation, and contribute to global knowledge, all while promoting economic growth and sustainable development across the continent. So that is, in summary, the objective of ASIAM. But below, we look at it in specifics. You can see the first one is we focus on local challenges and solutions, and provide a solution to local challenges as ASIAM. That is, in the context of looking at specific problems, that Africa faces specific challenges related to its economy, infrastructure, and environment, such as disease outbreak, climate change, resources management. ASIAM can direct research and application of mathematics towards solving these localized problems. So ASIAM is a society which is based on interdisciplinary concept and to tackle all these challenges. Innovation of Africa industry, for Africa industry, by promoting applied and computational mathematics tailored to African industries like agriculture, energy, healthcare, and technology. ASIAM helps create solutions that are directly relevant to local economy and the industrial needs of Africa. So that is our focus. The first focus is on local challenges and solutions. Promoting capacity building in STEM fields. So one of these, developing local talent. That is one of the major objectives of ASIAM. ASIAM is dedicated to promoting, providing training, mentorship, and professional development to students, researchers, and professionals. This will help develop homegrown talent that is capable of leading innovation on the continent. Networking and collaborations. ASIAM provides a platform for African applied mathematicians from Cape to Cairo, scientists and engineers to connect, collaborate, and share ideas. This will strengthen intra-Africa research network, help avoid dependency on external institutions for academic growth. So this platform provides a kind of collaboration and network among engineers, scientists, and applied mathematicians within Africa, and strengthen research and innovation ecosystem. That's one of our objectives. That's collaboration with international institutions. So ASIAM is not only linked with networking Africa, but collaborating with international institutions. ASIAM serves as a bridge between local researchers and global institutions like SIAM or European Mathematical Society. It can facilitate, that ASIAM facilitate the exchange of ideas, joint research projects, and academic partnership. The research funding and support. ASIAM advocates for increased funding for mathematical and scientific research across African countries. ASIAM lobbies government, international organizations, private companies to invest in applied mathematics research for the continent development. So our goal is also to make sure that we serve as a push to the government and organizations to assist in putting funds to support research in applied and industrial mathematics, to make sure that the continent is put on the global stage. Addressing the skill gaps and improving education. Curriculum development. ASIAM helps influence the development of STEM. STEM stands for Science, Technology, Engineering, and Mathematics curriculum in African educational institutions, ensuring that applied and computational mathematics is integrated into the learning system. This can prepare students for career in the field of science, technology, engineering, mathematics, and other related fields. So we make sure that all our high schools and so on, we make sure that they incorporate applied mathematics and computational science in their curriculum, so that when they grow up, children grow up in Africa, they can take career in science, engineering, and technology, and mathematics and other related fields, and be successful in contributing to the continent. Training educators. ASIAM facilitates the training of mathematics educators, improving the quality of teaching and equipping teachers, and we work with modern tools and techniques to inspire the next generation of scientists and engineers. That we train teachers as well, call them for workshops, and also we do a lot of interactions with our teachers to improve their communication and teaching skill of computational and applied mathematics in schools. Promoting African-led research and publication. As well known, we have African Journal for Industrial and Applied Mathematics. You can check our website. The journal is very feasible, and the journal has commenced to operate. So ASIAM promotes African-led research and showcases the work of African mathematical scientists through the establishment of African Journal for Industrial and Applied Mathematics, AGIAM. The AGIAM is already established, is there. This increased visibility and ensure that African innovations contribute to the global body of knowledge. Reduce brain drain. So that's part of the objective of ASIAM. ASIAM will help retain talents within the continent and boost its capacity for innovation. So that is one of our goals also, because when people are well trained and they can contribute to the continent and they have facilities, then there will no need for them to leave the continent and not to contribute what they have learned to development of the continent. fostering interdisciplinary application. Mathematics across discipline. ASIAM will foster collaboration between applied mathematicians and professionals from other sectors like medicine, agriculture, social sciences, engineering, information technology, etc., enabling interdisciplinary problem solving. In fact, the Society for Applied and Industrial Mathematics, Applied Mathematics and Industry, that's our society is a clear-based multidisciplinary society, interdisciplinary society, using mathematics as the bedrock in driving innovation. So that is the main objective of ASIAM, supporting the growing tech industry. Asia will play a crucial role in areas like machine learning, cryptography, financial modeling, which are essential to the success of the tech sector. So we play a very important role in that. Sustainable and development. So contributing to sustainable development goals. Asia will play a role in advancing Africa progress towards the United Nations Sustainable Development Goals. Mathematical models can help address issues such as food security, water management, renewable energy, and climate change adaptation. So these are part of the United Nations Sustainable Development Goals. So model can provide efficient and effective solution to that for sustainable development, and that is part of our goal. Climate change mitigation. Asia will work on developing models and simulations that predict the impact of climate change and design mitigation strategy for African nations. Economic growth and competitiveness. Enhancing industrial competitiveness. Asia will support industries by providing access to cutting-edge research and applied solutions that increase their competitiveness in global market. That is, our researchers will have interactions with African industry, and there'll be a lot of communication so that whatever research findings are put into market so that it can improve competitiveness in the productivity on our industries. Support for entrepreneurship. Asia will create a culture of innovation and entrepreneurship among African applied mathematicians and scientists. Asia will help transform mathematical research into commercial applications, spurring economic growth. So it's not going to be research for research's sake. It will be research for applications. And that is what ASIAM stands for. Promoting diversity and representativeness. Asia promotes the inclusion of underrepresented groups, such as women and people from rural or marginalized community. In STEM fields, it provides opportunity for mentorship, scholarship, and leadership development for young African mathematicians. So ASEAN, as ASIAM, African Society for Industrial and Applied Mathematics, we stand for inclusive representation in science and in STEM. So we promote that for women and marginalized groups in communities. So we boost science and technology in the community and expose them to scholarship, leadership, and develop their skill. Highlighting African advancement in mathematics. Asia will ensure that African contributions to the field are recognized and celebrated, improving global perception of African scholarship and innovation. Right now, we see that most of the work in Africa are not really recognized. Through ASIAM, one of our objectives is to make our work, the work of all African scientists, to be on the global map, to be visible so that they can see the contribution of African research scientists in the field of applied mathematics and industrial science and engineering to see their contributions. So our aim is to promote that. Building resilience against global crisis, that is epidemiological modeling and public health. ASIAM will develop expertise in disease modeling, helping African countries respond more effectively to future health challenges. You know, recently we have COVID and so many outbreaks can happen at any time, but ASIAM researchers and we coordinate and make sure that we can respond to these challenges and advise policymakers on what to do at the right time so that all these can help in the growth and sustainable development of Africa. Disaster risk management. ASIAM, via appropriate mathematical model, we help to predict and manage natural disasters. That is, ASIAM will work with government and organizations to enhance disaster preparedness. So these are about 10 points we put here as our objective. We welcome all the participants. You are to join ASIAM. You can go to our website. You will see the procedure of joining ASIAM. Your skills are needed for the development of the continent. Whether you are within Africa or outside Africa, we welcome everyone. You have categories of membership of ASIAM. So we want everyone to log in and join ASIAM, and we need your skill to put the continent on the map. These are the objectives of ASIAM, and we are working very hard to leave a very sustainable legacy for the continent to build upon in promoting science, engineering, technology, and mathematics within the continent. Thank you very much. Thank you. And I wish every participant a very successful contribution to this global celebration of mathematics worldwide. Thank you very much.
Thank you very much, Prof. Makinde, for that. I think we all took something from the 10 points that you have elaborated. However, I would like to believe that all these points are interconnected. The one that resonates with me the most is point number 6, which is really around fostering interdisciplinary applications, because mathematics is it's across all sectors. I believe that Prof. Atangana can attest to this, that he has applied mathematics all over, but with me, we have applied it in groundwater, and I'm really in the policy making sector, which looks into management of groundwater resources. So all these objectives, I can assure you that the leading mathematicians, they are doing all they can to ensure that they are being implemented and realized across all sectors. Just few ground rules, ladies and gentlemen. If you are not speaking, may you kindly mute yourself so that we can have a very smooth event. And I think the second one is that we do have a virtual round of applause. We can use the reactions. You can clap. I think that's very interesting and important. And then the last one, if we do have time, we will take some questions. However, now I will hand over to Dr. Ini, who will facilitate the next few hours. And I think we'll close off later on with our facilitator, Dr. Hans. Thank you very much, ladies and gentlemen. Over to you, Dr. Ini.
Good morning, everyone, and afternoon, wherever you are. Welcome to this session. I am honored to be moderating this discussion, and it gives us great pleasure to actually introduce our distinguished speaker, Professor Will Shenders. He is the chair of scientific computing in the industry in the Department of Mathematics and Computer Science at Eindhoven University of Technology, Netherlands. He is also a very leading figure in industrial and applied mathematics and currently serves on the International Council of Industrial and Applied Mathematics, ASIAM, Netherlands. With a remarkable career spanning both academic and over 30 years in the industry. Professor Shinders has made a significant contributions to computer systems, numerical analysis, scientific emphasis has always been for a large variety of industrial challenges, enabling technology, stressing its importance for industry and society. Today, he'll be sharing his insights as our key speaker. You are very welcome, Professor Will Shenders.
Okay, thank you very much, Dr. Inni, and for the kind words. And I will share my screen then with the presentation. I hope you can see it. Is it visible?
Yeah, yes, we can see it.
Okay, good. Okay, I'm very happy to participate in this major event, and thanks to Professors Andagana and Makinde for organizing this, and for all the people in ASIAM to work on this very important matter. Yeah, so what I would like to share with you is mathematics key enabling technology for challenges in industry and society. And it is indeed the International Day of Mathematics today, 14th of March. In the past, it was called Pi Day, but since 2019, UNESCO has recognized mathematics and made this the International Day of Mathematics. And it's really great to celebrate this every year, and especially with such major events as today. The contents of my talk about key enabling technology for challenges in industry and society. So you see some opening thoughts. Then I will talk about, on the one hand, mathematics for industry, and on the other hand, mathematics for sustainability. And Professor Makinde already touched upon that. Then a few brief words about ICIAM and also ICIAM and Africa. I'm retired already. I retired 2 years ago. I gave a valedictory lecture in 2023. But as you can see, my mission really is to use mathematics to get to a better world. And I think this is really a mission possible, not a mission impossible. So that's why I had this title for my valedictory lecture. Let's start with some opening thoughts. The role of mathematics is really very apparent. I mean, mathematics is everywhere. We are in a very dynamic world. Many things are happening, but mathematics is really present and also needed everywhere. And a colleague of mine in the Netherlands, he once said this statement: mathematics is like oxygen. You take no notice of it when it's there, but if it wasn't, you'd realize you cannot do without it. And that's really a very good characterization of mathematics, I think. For my part, I'm mainly working in simulations. And indeed, I mean, when computers started to exist in the middle of the last century, experiment and theory, they got a new part in simulation. And mathematics really plays a crucial role within the area of computational science and engineering nowadays. If you look at industry, virtual design environments are everywhere, and designing is done behind a screen. Not many tests are being performed anymore. And mathematical methods are really indispensable in many areas, like digital twinning or high-performance computing, and many other areas. But mathematics is often a bit invisible. I mean, I always show this mathematical iceberg. You see the top of the iceberg, but that's only a very small part. Many people do not realize how much of the mathematics needed to solve a problem is under the surface and invisible. And that's why I always say that mathematics provides invisible contributions to visible successes. A very prominent example, Volker Meermann, TU Berlin, he worked in the automotive industry. There was a phenomenon called disc brake squeal. It's really an annoying phenomenon. And the automotive industry had been trying for decades to reduce the squeal. The engineers worked on changing the design of the brake and the disc, but they didn't succeed. And then in 2015, the group of Professor Meerman started to work on this, and they did mathematical analysis, and it revealed bifurcations because the designs contained highly stiff springs used to avoid the rigid connections. And there were negative effects because of this, and that came really as a surprise to the industry partners that they had. And now all car manufacturers are extremely interested in the results. But it's clear from this that the hidden properties of the underlying system could only be revealed by mathematicians. Yeah, so here you see a splendid example of how mathematics can play a role in industry. But there is more. I mean, we all know that computers become faster all the time. And well, this is described by Moore's law. Every 2 years, the speed and density of transistors is doubled, although at the moment that is not true anymore, but it has been true for 50, 60 years. But what many people do not know is that besides the improvements in the hardware, the improvements in the mathematics have also been very apparent. And as you can see from this table, you see that the improvements in the mathware, in the mathematics, are actually outperforming the improvements in the hardware. And of course, these two effects have to be multiplied. Yeah, that's so if you look at linear programming, the hardware gets a factor of 1600, the mathematics 3300, and you have to multiply these two numbers to get the real improvement that people see. So, and also mixed integer programming. I mean, 25 years ago, it would take 180 years to do a simulation. It's now reduced to 1 second. But if you would only rely on computer speedups, it would still take 10 days. So the mathematics is extremely important. And Philippe Train said that I would rather use today's algorithms on yesterday's computers than vice versa. And I always say that if we would only rely on the improvements in the hardware and we would not have done any work on the mathematics, we would now be doing the simulations of the 1990s. So mathematics really plays an extremely important role. But also the economic value of mathematics is very high. You see here several reports that have been produced in the UK, Netherlands, Spain, and France, and also a nice book in Germany. And all of these reports have similar conclusions. Quoting from the Dutch report, the mathematical sciences contribute for up to 26% to total employment in the Netherlands. Furthermore, the economic contribution of mathematics is about 30% of Dutch national income. Well, these are very stunning figures. And a more recent report in the UK reveals even that if you want to invest money, then the best way to invest money is in fact in the mathematical sciences, as you can see compared to other disciplines. I mentioned the report by Philip Bond. It was very influential in the UK a few years ago, published in 2018, and in 2020 it led to an injection by the UK government of £300 million into mathematics in the UK. So I very much recommend reading this very nice report entitled The Era of Mathematics. Final remark on the opening thoughts. I mean, there is also a relation between, there's a correlation between mathematical ability and country competitiveness. Here you see the graph. On the horizontal axis is the PISA math score, which measures the mathematical ability of 15-year-olds. And on the vertical axis, there is the competitiveness index. And you see that there is a positive correlation between these two. So mathematical ability appears to be very important for a country to be competitive. Okay, these were the opening thoughts. Then let's concentrate on one aspect of mathematics, mathematics for industry. And there have been many, this has been realized already for many years. Yeah, so already in the 1950s, it was realized that mathematics is important for industrial challenges. Several organizations have been founded since then on the national, continental, worldwide scale. And in 2009, 2010, we did a project for the European Science Foundation, Mathematics for Industry, a forward look project, as it was called, with major recommendations and also this report, this book that you see here, containing success stories in industrial mathematics. And the report has actually led to a lobbying organization for mathematics in Europe, EU MathsIn. But there are many organizations in the world. Yeah, ASIAM is one of the oldest, Society for Industrial and Applied Mathematics, also mentioned by Professor Makinde, 1951. It's the largest organization worldwide. It has many journals and also many conferences. But there's ECME in Europe, European Consortium Mathematics and Industry. ASIAM, the organization that I'm leading currently, started in 1987. In Asia, there is the Asia Pacific Consortium of Mathematics for Industry, started about 10 years ago. EU MathsIn I just mentioned as a result of the report that we did. And I'm very happy that now we also have the ASIAM in Africa. Yeah, and I very much like the logo here, integrating all of Africa into this organization. Talking about doing work with industry, how do you contact industry? And one of the most successful ingredients is this study group Mathematics with Industry that we do a lot in European countries annually. It works as follows. On the Monday morning, it's a whole week. On the Monday morning, 5 to 6 industries present their challenges. Then the mathematicians choose their problem and they split into groups and they work on the challenges for about 3 days, day and night often. And then on the Friday morning, the teams present their results, sometimes solutions or partial solutions, the progress made, or maybe new research directions. So this is appreciated very much by industry, and often it leads to follow-up where there are further contacts and master student projects or even PhD projects. It was started in 1968 in Oxford. Alan Taylor and Leslie Fox, they organized the first study group. And in Europe, the organization ACME keeps track of the European study groups, and there have been about 200 until now. You can also look at our national website here in the Netherlands from my home country. Nice website. And in 2023, I was in Rwanda, and I was attending also the AIMS Global Fellows Program, which is very similar to a study group Mathematics with Industry. So this is one of the nice ingredients, one of the best ingredients to get in contact with industry. Besides that, we also work on booklets that show how important mathematics is and what you can do with mathematics. So it's very diverse. We published a booklet in the Netherlands and 7 years later in Germany. I will share the presentation later. You can look at these. Of course, it's in Dutch and in German, but I hope you can appreciate what's happening. And we're in fact currently preparing an English version with stories from all over the world. So I also invite African mathematicians to submit stories, and there will be this booklet in English. Now, Mathematics for Industry has been very successful. As the chairperson already said, I worked in industry for 30 years in the electronics industry, Philips, and we worked on semiconductor device simulation and electronic circuit simulation. At that time, we worked with engineers and physicists. Multidisciplinarity, also stressed by the chairperson, is very important. We worked with major companies, and it also led to novel mathematical methods, and that's really very nice. So we published 2 years ago this book, Novel Mathematics Inspired by Industrial Challenges. And what the book shows is that it's not just one direction from mathematics to solve industrial challenges, but industrial challenges also lead to new mathematics. And that is really an aspect of industrial and applied mathematics that should be stressed more and more. yeah, also in other areas there was progress, simulation of airflow around airplanes, weather models, financial mathematics, and many, many more applications. And there are also very exciting new developments in recent years, and they lead to challenges for mathematicians. For example, high-performance computing. As I said, Moore's law is practically dead, and so we need to go to parallel computing, but it has a big influence on the mathematical methods that we need to use for working on these high-performance computing systems. And also quantum computing, many mathematicians are working in this. It's not known what quantum computing will bring us, but mathematicians are preparing, at least for the future. There's also data science, very important, and artificial intelligence, and machine learning and neural networks. And some remarks here. If you look at high performance computing, for example, it's clear that first a lot of mathematics has to be done before you can even think about software and using hardware. So I propose to not talk only about software and hardware, but also about mathware, because that is a very important ingredient of the progress. And concerning artificial intelligence and machine learning, etc., many people are working in this, and it's often done in the area of computer science, but mathematicians must really work on this, and many are doing it right now. And I'm always saying that real intelligence is needed to make artificial intelligence work. And real intelligence, you can read mathematics also for that. And I think this is a very important part of artificial intelligence to make the methods more reliable and trustful. Yeah, so summarizing that, I mean, Karen Wilcox, very famous in the area of computational science and engineering, she says it's such an exciting time to be a computational scientist. And I fully agree. I mean, there are so many ingredients: high performance computing, data science, artificial intelligence. So there's lots of work for young people in this area to make progress and to produce nice mathematics. Okay, that was one part of the problem of the mathematics. Then there's also mathematics for sustainability, and Professor McKinder already mentioned it a few times. And I think this is also a very important subject, because the world really faces a daunting array of complex and interconnected challenges. I mean, there is food insecurity, there's inequality, infections worldwide, climate change, etc., etc. So there's many challenges that we are faced with as mankind, and also projected population growth patterns and climate change will impact and will intensify these challenges that we have. And mathematics is really capable of empowering sustainable development. Mathematics is fundamental to how we understand nature and the larger universe. For example, the COVID-19 pandemic, and governments all over the world rely on mathematics, not only to forecast the epidemic, but also to understand social issues like vaccine hesitancy. So mathematics really played an important role in this. And another example is weather prediction. 41% of the global population is at risk from tropical cyclone flooding. That's an amazing number, of course. But with new mathematical approaches, we can now predict the track of a cyclone up to 1 week in advance. And that gives communities time to evacuate and, of course, saving lives and reducing economic losses. So also here, mathematics plays a very important role. Now, we already 12 years ago, we had this worldwide initiative, Mathematics of Planet Earth, in 2013. It was a year-long worldwide initiative to showcase how mathematics can be useful in tackling global problems. And you can still look at the website, and it was really an international partnership of more than 150 societies, universities, etc. And the MPE 2013 year underscored the multidisciplinary nature of the problems that are facing our planet. If you want to know more, you can read about it on the website of MPE 2013. But there is more now. I mean, so in 2015, the UNESCO decided on an agenda for sustainable development. It was also mentioned by Professor Makinde, and there are 17 sustainable development goals that have to stimulate action over the next 15 years, well, starting in 2015. So we're already 2/3 into this period. And there are these well-known 17 sustainable development goals. Yeah, and mathematics really plays also an important role in all of these. There is a nice booklet that has been produced by mathematicians together with UNESCO. If you type mathematics for action in Google, then you will find this booklet and you can read about it. And it shows that mathematics really empowers sustainable development. So it's a mathematics for action toolkit, really, and it focuses on engaging stories of mathematics in action for sustainability, written by mathematicians. And it really provides insightful information for decision makers and for all those who seek proofs to challenging questions. Yeah, I'll give some examples here. Goal 1, sustainable goal 1 is end poverty in all its forms everywhere. And mathematics can play a role here by visualizing poverty. Yeah, so data techniques that are more accurate and more efficient than traditional survey-based methods. Then goal 6, managing, this is about ensuring availability and sustainable management of water and sanitation for all, also extremely important. And the, well, one of the stories is managing water resources, where it is highlighted how a statistical tool, Bayes' theorem, can be used to quantify risks and also identify options for the management of water supplies. The other story in this for this sustainable development goal is on shifting lake turbidity and approaches to restore clarity in water and in lakes, etc. Goal 11 is about making cities and human settlements inclusive, safe, resilient, and sustainable. And here is a story preparing for a crisis, and it deals with the resilience of digitized systems and also describes some of the mathematical methods and tools that have been invaluable for addressing vulnerabilities in the system. Yeah, so for all of the sustainable development goals, there are several nice stories how mathematics can be used. One of the important ones is in number 13. It's forecasting cyclones, mathematics of tropical cyclone prediction. As I said a few minutes ago, tropical cyclones are the biggest threats to life and property across the world. And it is really important to have improved track and intensity predictions so that we can give early warnings and evacuate people. And there have been major improvements in the tropical cyclone track forecasting. Yeah, and so we need these the mathematical understanding of the physical mechanisms behind cyclones so that we can also improve real-time intensity predictions. And that is the real-time aspect is very important here. We should not wait 5 weeks before, I mean, this should really be fast. Yeah, and we can do that in the following way. You see the input variables, there's lots of observational data from all kinds of sources. Then we have models, and the models are continually being improved, dynamical models, but also statistical models and numerical models. And then all of this, then the data and the models lead to forecasts of the cyclone track, of the intensity, but also of the storm surge and the rainfall. And the tropical cyclone tracking models have improved really a lot in the last 50 years. And the 2019 5-day track forecast was much better than the 1970s 36-hour forecast. So that is really a big improvement. Now, today, a cyclone's track can be predicted up to a week in advance. And well, there are improved mathematical models, and we also use revolutionary data assimilation methods for continuously adjusting the models with new observational data. But mathematics is also in other areas. There is a company in Finland, Arbonart, and they use mathematics to help in forest management decisions. Yeah, so they work all over the world, and their mission is to promote responsible forestry by creating digital twins of forest ecosystems. And the mathematics they use is really Bayesian modeling. They use machine learning and also morphological geometry and apply this to forest stand delineation. So very important work as well all over the world for these forest ecosystems. But also in climate energy transition, mathematics is important. Here you see a wind park in the North Sea, and this is Hornsrev in Denmark. It's the world's largest offshore wind farm. And there's a lot of things happening in these wind farms. It's also mathematically very interesting problem. There's water vapor. It condenses at the tips of the front row of the wind turbines. And here you see in the picture the turbulent wind flow through the wind farm, and obviously it will influence the effectivity of the other windmills further into the sea. Yeah, so also here we have that no offshore wind energy can be done without mathematics. And a final example is in our home country, we have the Center for Mathematics and Computer Science, and they analyze actually the electricity and gas networks. And nowadays, people are contributing to this by having solar panels on their homes. So we are not just taking energy from the system, but we are also delivering energy to the system. And this really leads to, well, instabilities, potential instabilities in power grids. And a mathematical framework, many people are working on this, many mathematicians. It helps to predict the appearance of potential power line failures. And here you see how this works in the German system, the German transmission network. The blue and the yellow nodes represent wind and solar parks. So you see lots of wind parks and solar parks in Germany. And well, the potential critical lines are given in red here. And mathematical analysis really makes sure that these networks become much more stable. Talking about sustainability, we can also work on sustainability by reducing what we do on energy consumption. I mean, for example, the internet accounts for about 3 to 5% of global energy consumption. And it's unknown how much simulation is costing in terms of global energy consumption. But also with things like ChatGPT that people are using more and more, the energy consumption will go up. And an astronomer in the Netherlands has made an analysis of this. We'll quickly show two figures. Here you see the CO2 emission as a function of time for a variety of popular computational techniques used in astrophysics. And you see that there are enormous productions of CO2 by the simulations. And what's even more interesting maybe is that it also depends on the software that you use. I mean, Fortran seems to be very favorable, but if you look at Python, that's not doing a very good job. So even this influences the energy production. So we have to be very careful about this. And also in our simulations, I mean, we can have more and more faster and larger and larger simulations. But here you see an estimate of the energy needed for these simulations. And sometimes you have to say, okay, stop here because it's becoming much too expensive in terms of energy consumption. Yeah, so and this also holds for high performance computing. Computers nowadays turn to being parallel, a mixture of CPUs and GPUs, and the mathematical methods used in these simulations must therefore be scalable. Yeah, so not too much communication between processors, and we have to revisit most of our methods. And this provides also big challenges for mathematicians. High performance computing often requires a lot of energy, and there are methods to reduce this. I mean, think twice when you start doing simulations. Yeah, and one of the areas I worked in is model load reduction. I always explain it with the rabbits. I mean, if you see this picture, you will immediately see it's a rabbit. So you don't need a very detailed description that you see in the middle or on the left. And the same holds for the simulations that we're doing. Often we can get rid of a lot of detail in the simulations and make smaller simulations, and that will obviously be less demanding for the energy consumption. Here you see an example that we did on large resistor networks. You see the performance of the commercial codes. We developed a model load reduction method, and you see it is much, much faster and clearly also uses much less energy. So mathematics in the high performance computing area, many challenges for mathematics, new methods, complete revision of the methods, and there's also an urgent need for methods to reduce the enormous energy demand. And a few years ago, this report was published, Applied Mathematics Research for Exascale Computing, and it leads to, hopefully, to energy saving and to much more sustainability. Okay, final few words about the organization ASIAM. So some basic facts. It was started in 1986 by a number of organizations for industrial and applied mathematics. And ASIAM works to advance the applications of mathematics in all parts of the world. Our main activity is an ASIAM Congress. It's held every 4 years. The first Congress was in Paris, 1987. Then we had several cities all over the world every 4 years. Tokyo was the last one in 2023. And the next Congress will be in The Hague, 2027. We are currently discussing where it will be in 2031. The choice will be made in September. And maybe Africa could be a candidate for 2035. So there's something to think about for you. Number of participants steadily growing, more than 5,000 in Tokyo. And well, organizational structure, we have 10 board members at the moment that meet every month. And there's a board of consisting of the representatives from each of the member organizations. And that's currently 54, and that's meeting once per year. And here you see the members that we have of ASIAM. So you see it's really all over the world. We have members, and it's growing. We also have some collaborations with the International Mathematical Union, also with SIMPA that you might know. It's also active in Africa. And also ASIAM is a full member of the International Science Council. We have prizes, important prizes, the Collatz Prize, the Industry Prize, Lagrange Prize, and then also the Maxwell Prize, Pioneer Prize, and Subukin Prize. And these prizes are handed out every 4 years during the opening of the Worldwide Congress that we organize. Some other activities, we meet with member societies in several areas of the world. And we do sponsoring of workshops, up to 3 conferences in industrial and applied mathematics. And this sponsoring is for supporting fellowships for participants from developing countries. We also have a quarterly newsletter, Dianoia. And here you see the January 2025 edition. And you can subscribe to Dianoia if you go to our web page. There's also a flyer on our webpage where you can read more about our prizes and what we do precisely and where the conferences are being held. Final word on ASIAM and Africa. So right now we have SAMS and SAMSA on board, and also a new member since the beginning of this year, the African Mathematical Union. So that's really great. But of course we can grow more. We welcome more African members. Mathematics is alive and kicking in Africa. Many renowned and talented mathematicians. There was a nice event, ASIAM 2024 in Cape Town last year. And events like this are very important to bring mathematicians from all over Africa together. And well, key is the organization at the national and continental level. So members of ASIAM are unions of applied and or industrial mathematics. So you can think of starting such a union. And together we are stronger, yeah? So we can convince policymakers together to fund more mathematics. So AIMS and ASIAM may also qualify as members. We need to discuss this. Now, it would be great if more African mathematicians could attend ICIAM in The Hague in 2027. So you're all invited to this nice event. And hopefully there will also be a new ASIAM conference, but Professor Atangana can tell us more about that, to be held in 2026, I think. And talking about invitations, there will also be a nice event in a few months in Cape Town. I will be also one of the speakers, and it's a mega math festival organized in Cape Town. So all invited to that as well. Let me quickly conclude then. We live in the era of mathematics. Its influence permeates economic and social activity. Influence and impact are really profound. Mathematics plays an extremely important role in industry. For example, in development of digital twins, addressing complex challenges and boosting innovations, but also in other areas, societal challenges. Yeah, sustainable development, for example. We should take care of the abundant use of the internet and high-performance computing facilities. We can reduce that. Think before you start to compute. Do first the mathematics. And really making use of the mathematical toolkit and the mathematicians will reduce the burden on computing services. But we can also do much better by investing more strongly in mathematics, great benefits at a relatively modest cost. It's only the mathematicians, not big machines or whatever. Yeah, and this could all lead to a better world for all of us. And I really hope that especially the young and talented mathematicians will be ready to drive this challenge. So we made stickers, and I think you can put these stickers on almost all products, because mathematics is inside everywhere. Yeah, so this is really the message that I wanted to convey to you. So I thank you for your attention.
Thank you very much. I think we should give a round of applause to Professor.
Thank you.
Okay, all right. So our takeaways is so much that I do not really know where to start from. You know, here we can see that from your discussion, we are really in the era of applied and industrial mathematics. And the role of mathematics, in your own words, is extremely important from all the talks that's from your talk. And I don't even know where to start from. Like you said, mathematics is everywhere. And mathematics provides invisible contribution for visible success. This is really, really great. So we are really, really excited about this talk and what it is really pushing inside of us. And in your talk, we can see work done, work in progress, and exciting, brilliant ideas for future work. So this is really great. And then another take home is that together we are stronger, and then we should do the mathematics first, and then definitely we are going to see maths inside everything. So thank you so much, Prof, for your wonderful talk. And I really want us to give him another round of applause, please. Thank you. We are really delighted, and thank you so much. And we truly appreciate your time and expertise. Thank you.
Thank you very much.
Yeah.
Prof. Will, before you go,
I will attend the next lecture, but yes.
Yes, before you go, you said you are thinking if the next time will be in Africa, 2035.
Yeah,
Myself
35.
and Professor Makende and Young African are saying Africa is not a singularity. It is a part of the world. So 2035, this will be hosted here in Africa.
Yes.
25 or what?
35. 35.
Oh, 35, yes. Okay.
Yeah, yeah.
You will have to bid for that, of course. There is competition. As you can see, for 2031, there are 3 cities competing, so you will have to compete. But I think you will have a very good chance.
Yeah, you have a very good chance because that will be the first time to bring it to Africa.
Yes,
So
absolutely.
myself, Professor Makende, Professor Bakare, all the regional president of ASIAM are going to work very hard to make sure that the conference can be here in Africa.
Yeah, and the bidding will start in about 2-3 years. So if you prepare now, then you can have a good bid, and yeah.
Okay.
Yeah, no problem. Yeah. We work hard for it and get it in Africa.
Yeah, I'm very impressed by what you did so far in a very short time. I mean, on ASIAM, etc. So it's really you can do a lot. Yes, I'm very impressed.
Thank you very much. And maybe very soon, ASIAM will produce the book African Success Stories in Industrial Maths, just like the one that you told us about. So we're
Yes.
making progress, yeah. So thank you very much. Yeah. So without wasting time, we will go on to the next lecture, and that will be given by Professor Thomas Kozubek. He's from the Technical University of Ostrava, Czech Republic. He's a scientific director at IT4 Innovations National Supercomputing Center and a professor of applied mathematics at VSB Technical University of Ostrava. He specializes in the development of scalable algorithms for massively parallel solutions to engineering problems. He is the author or co-authors of over 70 articles published in conference proceedings and journals.
Hello?
He was or is the principal investigator for the Czech Republic of the project focused on high-performing computing. So please, and today he's going to be presenting a talk on advancing HPC research and infrastructure, the role of IT for innovations in the European context. Please join me as we welcome Professor Thomas Kozebek.
Okay, hello everybody. I hope you can hear me.
Yes.
Okay, perfect. I will share my presentation. Okay. Okay, now please, can you hear my presentation in presentation mode?
We can see your slide, but it's you need to
Okay, I will.
bigger.
And now?
Okay, better.
Yes.
Better now.
Better. Perfect. Okay. Okay. Perfect. Okay, it means thank you once again for kind words. And I would like to focus not exactly on mathware, but much more on hardware and software technologies, which we developed at IT Innovations. And I would like to, let's say, somehow relate them to the European context. And I would like to say also about the European HPC, quantum computing, and AI environment. But first, I will start with some introduction of IT for Innovations. We were established in 2011 in Ostrava, in the Czech Republic, as a university institute of Technical University of Ostrava. And but we play also another role. We are a member of E-Infra CZ, which is a large strategic research infrastructure of the Czech Republic. And together with other partners, CESNET and CERIT, we somehow operate and provide special infrastructure, not only those supercomputers, but also connectivity. We ensure connectivity for education and research, also some data storages and data services, cloud services, video conference services, and many others. In this moment, we operate two supercomputers, Barbara and Carolina, and we also cooperate one of the largest supercomputer in Europe, which is called LUMI, and I will say a few words about those supercomputers later. In this moment, we have 5 research laboratories. It's about 100 full-time equivalents, and people in those laboratories are focused on high-performance computing, data analysis, artificial intelligence, and also quantum computing. We are a member of many different initiatives, infrastructures, European infrastructures, and European organizations. I will say a few words about Euro-HPC joint undertaking, which is very important for us and support the whole HPC environment in Europe. On the next slide. We have also strong international collaboration. It's about 20 European projects, mainly from Horizon Europe and Digital Europe. Horizon Europe and Digital Europe are the largest programs which support research and development and also innovations and the related hardware and software technologies.
Hello, sir. Hello.
Hello. We cooperate with industry and the public institutions. We have 2 platforms for such collaboration. One of them is National Competence Center in HPC, and the second one is European Digital Innovation Hub. And those platforms are focused really to support industry with respect to digitalization. And we offer also a lot of training and educational activities in the mentioned fields. Okay, I promise that I say a few words about Euro-HPC joint undertaking. It was established in 2018, and it's composed of 35 member states and 3 private members. And the focus of this Euro-HPC joint undertaking is to federate high-performance computing and quantum computing and also AI infrastructure. And to support also European technologies and applications for HPC ecosystem, and to support education and training skills. This program, let's say, took money from this largest European program from Digital Europe, Horizon Europe, and also Connectivity Europe programs, and doubled them by contributions from member states. Yeah, it means there are a lot of money to support all the goals I mentioned. And here you see the result. It means here you see the federated high-performance computing and quantum computing infrastructure. It's not completely federated because in this moment we have all pre-exascale and petascale supercomputers which are now in operation. And this year will be in operation also exascale supercomputers, Jupiter in Germany and Alice Rocoq in France. And you can see on the background the map of Europe and also Czech Republic, which is here. And in the Czech Republic, we have supercomputer Carolina, which is also European, Euro-HPC supercomputer, and also quantum computer, which I will speak about later. Okay. Thanks to this Euro-HPC joint undertaking, we have also within top 500 largest supercomputers in the world, we have also registered a lot of supercomputers from this Euro-HPC joint undertaking. In top 10 or top 11, you can see supercomputers Lumi. I will mention a few words about later, and also Leonardo, which is in Italy, and also Mare Nostrum, which is in Spain. Those 3 supercomputers are Euro-HPC supercomputers. Okay, here you can see also some statistics related to these big supercomputers and their use. You can access them within Europe through special access mechanism, extreme scale access, regular access, and also special one which is focused on AI and data intensive applications. And you see that it's statistics related to 2024 that about 300 projects were supported. And you see that those projects are from completely different fields. A lot of them from chemical sciences, 25%, and materials, 11% from earth system sciences and environmental studies, 27%, this green part, it's engineering, mathematics, and computer sciences. The blue part, the biggest one, it's computational physics, mainly astrophysics. Yeah, and also the remaining part is bioinformatics. Okay, here is some, say, short history of our supercomputers, which we have at ITF Innovations. You see also some Anselm and Solomon, this black and white. They are decommissioned in this moment. And now we operate supercomputers Carolina and Barbara, and also cooperate supercomputer Lumi, as I mentioned. In this moment, we have also some, or I have also some news for you that we plan to have a quantum computer. The implementation will start next week, and the name is VLQ, VLQ, and I will say a few words in the next slide. And also, because supercomputer after, let's say, 5-6 years is not it's not possible to operate anymore. It means we will replace also Barbara supercomputer by a new generation one. Okay, a few words about Carolina supercomputer. As I mentioned, it's Euro HPC supercomputer, and here you can see why. Because 2/3 of money is paid from the Czech funding, and the remaining are from EU funding, particularly from this Euro HPC joint undertaking. And therefore, 1/3 of the resources is offered to users from the whole Europe. It's for 15 million euro, the total investment, and the theoretical peak is about 16 petaflops. It means 16 times 10 to 15 operations per second. In this moment, there is about 2,000 active users, and they are solving about 700 different projects in different areas. Okay, and the very important part of Carolina is this accelerated part with 72 servers, and altogether it has 600 GPUs, and you know that GPUs are very important for training of different neural networks and different models. Okay, here you see only some, let's say, pictures, some illustration how such supercomputer is installed, and that it takes really a lot of time. Yeah, when you start, for example, here in December 2020, and when it was put into operation for users in July 2021, yeah, it means more than 6 months to put into operation such supercomputer. Okay. Here is one slide about Lumi supercomputer. It has more than 500 petaflops, and it's the power. It's like the power of more than 1.5 million of modern laptop computers. And when it was put into operation, it was number 3 in top 500, and also in number 3 in Green 500. Green 500 means that it's not with respect to the performance, but with respect to energy consumption. And the total price is more than 200 million euro. Yeah, if you can compare it with Carolina, which was for 15 million euro. Okay, and we have 2.5% only for the Czech Republic and for scientists from the Czech Republic of the total performance of Lumi. It seems that it's something small, but it's like another Carolina supercomputer. Yeah, it means it's really a lot. We have also visualization virtual reality labs at ITF Innovations, and they are directly connected to our supercomputers. It means you can simulate and run different simulations on our supercomputers and immediately in real time watch everything in our 3D cinema or in our headsets related to virtual reality. And here you can see also users. Who are our users from the Czech Republic? You see that it's institutes of Czech Academy of Sciences. It's the most important user. Then it's all large technical universities in the Czech Republic and large research centers. And what they compute, you see that almost 60% is material sciences. Then it's physics and astronomy, computer science, biosciences, earth sciences, and also applied mathematics and engineering. And we have also different possibilities to access our supercomputers. One of them is regular access, which is open every 4 months. And there is also special fast track access, which is continuous. And if you want some resources in 1 week, you can use this fast track and you can start to work on our supercomputers. Okay, and here is one slide about our training activities. We offer about 40 different activities which are open for everybody. Yeah, you see that 50% of our participants are foreign researchers, and altogether that we had about 900 participants. And our courses are focused on high-performance computing, how to use efficiently HPC on our supercomputers, how to use and apply quantum computing algorithms, and some training focused on data analysis using R, Python, and a lot of courses focused on AI. And some of them are for beginners, some of them are for advanced users. Okay, and now I promise that I will say also a few words about our quantum computer and some news related to IT innovations. Within consortium, which is called LumiQ, maybe if you remember, Lumi is the name of the supercomputer, one of the biggest in Europe. And it's also a consortium which operates this supercomputer. And LumiQ is part of this consortium, which will operate a quantum computer, which will be here in Ostrava, in the Czech Republic, at IT Innovations Data Room. And within this consortium, we will install and we will start next week with this implementation such a quantum computer. Here is an illustration. And this quantum computer will have 24 physical qubits. It's to the topology is a star-shaped topology, and you can see also some special parameters of this quantum computer. The most important are the phasing time, which is 20 microseconds. It means all simulations which you run on such quantum computer must be executed within this 20 microseconds. And another parameter very important is this fidelity, which means something like accuracy. And it's in this moment only 10 up to -2. Yeah, if you have doubles, double precision, it's 10 to -15. But don't worry, within 3 years, it will be 10 to -10, -8, yeah, which is predictions related to developers of such hardwares. And on the picture, on this illustration, you can see cryostat and some special system for measurements, and also a lot of compressors, and it will be cooled by helium because we need 0.1 millikelvin, the temperature related to that. Okay, and here is how it will work, it will be integrated with our supercomputer. It means on the left here you have HPC machine, Barbara, Carolina, etc. And you can log in to this HPC machine and prepare your job and put it to the queue, and then there is some scheduler and which runs efficiently these jobs. And if some part of the job will be related to quantum computer, then this part will be offloaded to this quantum computer, efficiently computed using this. and return back. Yeah, it means it will work as a quantum computing accelerator, yeah, in our architecture. And we are in this moment preparing the software stack to run this environment in this way. Okay, I mentioned also that Barbara will be the old one, the old Barbara will be replaced by new generation of Barbara. Also this year, it will have more than 140 nodes or servers with Intel Granite Rapids processors and a lot of memory per server. It means a lot of memory-bound programs will be run very efficiently. And another news is that we succeeded also in a special Euro HPC call focused on AI factories. We succeeded again with our LUMI consortium, and we will build one of the biggest AI factory in Europe. In this moment, the biggest one. And this factory, it will be again a very big supercomputer accelerated with many tens of thousands of GPUs. Yeah, it means it will be for really very large language models and processing of extreme data. And such AI factories will be 12 in Europe. And we succeeded also in a Clara project. It's a Teaming for Excellence. It's one of the most prestigious European project, European call. And it's focused on building Center for Artificial Intelligence and Quantum Computing and for research, for brain research. And you can see also partners, main partners are from the Czech Republic, but also one from Germany and a university hospital from France. And there will be also some special test bed, which will be situated in our data room at IT Innovations, focused on, it will be again simply some supercomputer accelerated by many GPUs. Okay, and here is only some illustration, some cross-section of our building. It means it's not only about supercomputers and data room, but there are a lot of operating or supporting technologies related to fire prevention, related to cooling, and related to if you have, for example, some blackout, you must keep alive your supercomputers in life for some at least seconds. And therefore, we have also this dynamic rotation UPS, etc. And you need to, of course, if you want to add more and more supercomputers, you need sufficient power supply and cooling capacity for future technologies. Okay, and if you want to access supercomputers, don't worry, you don't need to know, you don't need to go through command line and need a lot of about Linux and about parallel programming, etc. Now you can access supercomputers very simply through very nice graphical user interfaces. One of them is open on demand. You can upload your data very simply, and you can run everything on supercomputers. For example, your favorite codes like ANSYS, Blender, ParaView, and MATLAB, and many others. At IT Innovations, we develop some alternative to this open on demand, which is called the Lexis platform. And it enables easy access to HPC and cloud computing. It's focused much more on complex computing workflows, on safety, and also on distributed data management. And with these tools, it was possible to win or to won a special tender for this federation. Yeah, this is slide I mentioned earlier, but I mention it again because this platform will be based on the, let's say, tools or parts of this Lexis platform, which was developed at IT Innovations, which we are very proud that this federation, European Federation of Supercomputers and Quantum Computers, will be based on this Lexis. Here, almost last slide, some, let's say, examples related to our research and innovation. It means typical thing is creating digital twins. In collaboration with Siemens, we created digital twin of electric motor. A lot of things related to virtual prototyping, a lot of applications in energy industry, optimization of energy distribution, for example. And again, if it's only small city, it's very easy. But if it's the whole Czech Republic or part of Europe, you need really the big power of supercomputers. And I mentioned Lexis. We develop a lot of smart platforms. Here I mentioned only Floreon Plus platform, which is for floods recognition, or floods simulation and predictions, and also in combination with traffic and air pollution and many others. This platform was used, for example, by rescue services and fire brigades during recent floods in the Czech Republic. And a lot of other platforms in collaboration with European Space Agency, which are focused mainly, for example, on urban analysis, etc. Here you can see titles or logos of our projects, European projects. Most of them are focused on research and development, some of them on support to industry, some of them on infrastructure development and education, which is very important. Okay, and who is behind this? IT for Innovations employs about 180 people, and you see that 20% is management and administration, 40% are people who are responsible for supercomputing services, and two-thirds is people or researchers in 5 laboratories, advanced data analysis and simulation, modeling for nanotechnologies, parallel algorithms research, infrastructure research, and quantum computing. Yeah, and here is also some structure of our finance, about 40% from national projects. It's related also to supporting of our infrastructure, 20% from some structural European funds, 18% from international projects, and 10% from some institutional money. And you see here, for example, some, let's say, illustration. And if you have some, let's say, if you need some information, you can find them at our webpage. And if you want to be our user, we have this docs IT for ICZ where you can find all information. Okay, thank you.
Thank you very much for enlightening us on these very, very important tools that we use now. You know, I wish we had time to ask questions because I'm sure that some people want to know a lot of things. But then I have this concern because in your talk, you said in applied mathematics, just about 2% are really using these supercomputers for Africa around. So I was wondering, maybe is it that most mathematicians are not really exposed to the use of these tools? You know, that's something that I was thinking about. Then another thing I wanted to find out is that do we have, we in Africa, do we have access to these supercomputers? Because you said there's this open demand, the Lexus platform. So is it that people in Africa can access it for free and do their computing work and stuff like that? I just want to find out.
Okay, I will start with the first question. There was, okay, if you remember at the Euro HPC level or European level, there were bigger percentage related to applied mathematics. In our case, it's 2% because mathematics is everywhere, yeah, in each field I mentioned. But when the project proposal is submitted, they decide, the project investigator of this proposal decide in which category is his project or her project. It means it's up to the decision of this project investigator. It means if it's computational chemists, they use this chemistry or material design, etc. Yeah, it means it doesn't matter. It doesn't mean that there is only a little mathematics, because mathematics, as we discussed, is everywhere. Mathematics and algorithms.
Okay.
And the second thing, it's about Africa access. It's possible through collaboration, for sure, and through some special accesses which are related to this collaboration. It means directly it's for people from Euro HPC member states, yeah, which covers somehow the whole Europe. But through collaboration, for example, with IT for Innovations or with some unit or some supercomputer center in Europe, it's possible.
Oh, okay. Okay, thank you. Sorry, we don't really have time. I'm sure a lot of people would have wanted to ask you some questions, but we really thank you for this talk and really appreciate that you had time to come over. So please, I want everybody to give Professor Kozebek a round of applause. Thank you so much. Thank you.
Also, thank you.
Okay, so I think we'll go to the next presentation, and we have the next speaker is okay. We have Professor Kovanogo Ladisva. Sorry about the pronunciation. He is from the United States Technical University, Russia, and he's of the Faculty of Computational Mathematics and Cybernetics. He has some specialty in industrial thermal power engineering, and he's a professor with also some specialties in mathematical modeling, numerical methods, and software packages. He is a full member of the European Society of Computational Methods in Science and Engineering, and also an accredited expert of the Russia Federal Register of Experts in the scientific and technical field, and also performs expert work for the Russian Ministry of Education and Science for scientific foundations and organizations. Like I've mentioned, his area of scientific interest includes thermophysics and heat engineering, design and optimization of power plants, heat and massive transfer, computational fluid dynamics, and applied mathematics and numerical methods. He has achieved a lot in the development of the field of mathematical modeling and research. And we are very happy to have him because he's also the one that is head of the leading scientific school of the Russia Federation in the field of energy and has trained several PhDs. But today he's unavoidably absent, and then in his place we have his representative, and she is Dr. Maria. And the talk will be on development of computational fluid dynamics methods using machine learning to solve applied energy problems. You are welcome.
Hello, is it visible, my presentation?
Yes, I can see it.
Good afternoon, dear colleagues, friends, ladies and gentlemen. My supervisor, Kovalnogov Vladislav Nikolaevich, asked me to make our presentation to the conference. Before I begin my speech, I would like to thank the organizers of this African Society for Industrial and Applied Mathematics, and especially the President of the African Mathematical Union Commissions for Research and Innovation, Professor Dr. Abdona Atangano, for the opportunity to speak at such prestigious international event. This is a great honor and pleasure for me to be here and to speak here. Thank you very much. I am a junior researcher of the Laboratory of Interdisciplinary Problems of Clean Energy Production at Ulyanovsk State Technical University. The laboratory was created with the support of a mega grant from the government of the Russian Federation and carries out research in the field of developing methods of applied mathematics to solve problems of environmentally friendly, sustainable energy. In my speech, I talk about the research carried out by our group at the laboratory. The outline of my speech today is proposed as follows. In the first part of my speech, I plan to briefly talk about the city of Ulyanovsk, about Ulyanovsk State Technical University and the laboratory that I represent here, as well as about the research project that we have implemented and are currently implementing. I talk more about the experience of using machine learning methods to solve energy problems. So let's begin. As you know, the Russian Federation is the largest country in the world by area, occupying a significant part of Eurasia and the eighth of the Earth's land. It's rich in natural resources, diverse landscapes, and cultural heritage. Russia plays an important role in world politics, economics, and culture, and is also known for its achievement in science, art, and sports. The city of Ulyanovsk is the administrative center of Ulyanovsk region, located in the very center of European part of Russia and is located on both banks of the great Russian river Volga. The population of the city is more than 600,000 residents. The city is not big, is not small. One can say typical provincial Russian city. Due to its location, Ulyanovsk has a development transport infrastructure. In addition to the network of roads and railways, the city has 2 international airports, a passenger river port, and 2 river sea cargo ports. Ulyanovsk is the birthplace of a world-famous revolutionary and founder of the Union of Soviet Socialist Republics, Ulyanov Lenin. Therefore, in addition to the name of the city, a significant part of the city's sites and museums are associated with Lenin. Ulyanovsk is a large industrial cluster with developed automobile and aircraft manufacturing, electronics and control systems, and military equipment. It is in Ulyanovsk where a Russian Jeep UAZ and Tupolev and Ilyushin civil aircraft are manufactured. The Ulyanovsk region also has a fairly developed agricultural sector. Ulyanovsk is integrated into the unified energy system of Russia while actively developing renewable energy. A large wind farm with a capacity of 85 megawatts was built and put into operation in the industrial cluster on the left bank of the Volga River in 2018. The facility has 28 wind turbines. The energy they generate is supplied to the Russian wholesale electricity market. Being a large industrial cluster with energy-intensive industries, the issues of sustainable development related to respect for the environment, neutralization of the technology's impact over urban areas, sustainable energy, and energy production from renewable sources, including municipal and industrial waste, are extremely relevant for us, as well as for many similar areas in the developing world. As an illustration of this issue relevance, on the slide I presented a selection of links to government documents on the strategic development of the Russian Federation, the Ulyanovsk region, and certain industries. Of course, all the documents are in Russian, but for who are interested, translating is not a problem. I think a significant role in solving these issues is given to scientific and education centers. There are 5 state universities in Ulyanovsk. There are the Classical University, our Technical University, Agricultural University, Pedagogical University, and the Institute of Aviation. Ulyanovsk State Technical University trains engineering and management personnel, as well as a highly qualified personnel for the real sector of the region's economy. Some milestones in the history of a technical university are presented on the slide. In 2027, the Technical University will celebrate its 70th anniversary. Our university takes a leading position in Russia in terms of a number of issued patents for inventions, and in the period from 2000 to 2014, it was recognized as #1 in this indicator. The university has 8 facilities. This is mechanical engineering, power engineering, civil engineering, radio engineering, engineering and economics, a faculty of information system and technologies, humanities, extramural faculty, as well as 3 institutes: Continuous Education Institute, International Institute, and the Institute of Aviation Technologies and Management. The next 2 slides present the characteristics of Ulyanovsk State Technical University in figures. The university has about 1,000 students, including about 600 foreign students from 28 countries. By all Russian measures, the university is neither large nor small. It is a typical provincial Russian university of federal significance, financed by the state and aimed at training engineering and management personnel for the regional economy. Our laboratory of interdisciplinary problems of energy was created at Ulyanovsk State Technical University in 2021 as part of a state mega grant program of the government of the Russian Federation. And now I will tell you very briefly about our laboratory and the research we are carrying out. So the name of mega grant project development of methods of applied mathematics to solve interdisciplinary problems of environmentally friendly power generation from municipal and industrial waste. Project objective: the creation of a world-class scientific laboratory and the development of efficient methods of applied mathematics for the solution of interdisciplinary problems on the environmentally friendly power generation from urban and industrial waste, including the machine-based search for breakthrough technological solution and development, research, and optimization of their digital twins. It is clear that the laboratory was not created out of thin air. The personnel base of the laboratory was formed by the Scientific School of Ulyanovsk Thermal Engineering and Thermal Physics that had already been established by that time. The founder of the scientific school was Doctor of Engineering Professor Nikolai Nikolaevich Kovalnogov. The scientific interests and developments of the school were aimed at modeling, research, and optimization of thermal and fluid dynamic processes in elements of power plants, heat engines, and process equipment. By 2020, our scientific school was recognized as the leading scientific school of Russian Federation in the field of power engineering, having received the state support from grants from the President of the Russian Federation. More than 36 candidates of technical science and 2 doctors of technical science have been trained. More than 30 research projects have been implemented. More than 100 patent results of intellectual activity have been created, and more than 600 scientific articles have been published. In essence, the school with high efficiency prepare highly qualified personnel both for its own reproduction and for the regional economy. Thus, on average, out of 2 bachelor in thermal engineering graduated annually. We prepared several masters of engineering and technology and 1 candidate of science per year. Currently, the school trains postgraduate and doctoral students in the range of scientific specialists presented on the slide. The leading science of our project is Professor, Academician of the European Academy of Science and Art Theodore Simas from Greece, a major specialist in the field of computational mathematics and numerical methods, who has repeatedly been included in the top 1% of the most cited researchers in the field of mathematics according to Clarivate Analytics. We began our collaboration with Professor Simon in 2014. I would like to note that today In addition to Professor Simas, another leading scientist with world-famous name works in the laboratory, which is Professor Mikhail Alexandrovich Sheremet from Tomsk State University. Both of them are among the top 100 researchers in the world in their field, according to Web of Science ratings. Professor Simas in the field of mathematics and Professor Sheremet in the field of interdisciplinary research. Joint work and scientific internship under the guidance of such giants provide invaluable experience and motivation for the professional growth. During the implementation of a project, a unique infrastructure was created and equipped with modern equipment and computing technology in the laboratory, allowing for the solution of a wide range of practical problems and including three centers. First, the Analytical Center for the Development of Effective Mathematical Methods for Solving Interdisciplinary Problems of Clean Energy Production. The second, Center for the Development of Digital Twins of Technological Solutions for Clean Energy Production. The third, Engineering Center for Prototyping, Digital Things, Testing, and Optimization of Technical and Technological Solutions, preparing them for implementation in the real sector of economy. The laboratory employs about 40 people, including 3 postdocs, 10 young candidates of science, 8 postgraduate students, and 12 students. The laboratory employees implemented more than 15 research and innovation projects. In the period from 2021 to 2024, some of which are presented on the slide. The projects involve modeling liquid and gas flows in the flow path of power machines, optimizing combustion process, analyzing the aerodynamics of wind farms, and designing more efficient blades. Detailed